A reminder from last time, a couple of reminders from last time. What was our reminder about the stoppers that are inside of the solutions? What was that? Don't mix them up, okay? Don't cross-contaminate. Thank you. Make sure that you're not cross-contaminating because that will alter our results. The other thing I wanted to remind you of, what kind of evidence are you looking for physical changes?
Changing appearance.
Change in appearance. And what kinds of changes are you looking for chemical changes?
Changing color.
Sometimes a change in color.
Like the form.
Say that again.
Like the form.
What about the form? If you make a new substance, that would be an evidence. Okay. So make sure that you're referring back. Excuse me. Make sure that you are referring back to the pre-lab statements that we made about chemical changes and physical changes. Okay, you have the period. I'll be coming over to talk to you about what you're doing, so make sure you're paying attention to what's happening. Okay, is this a chemical reaction?
Chemical.
How do you know it's a chemical reaction?
The bubbles.
There are bubbles. Anything else?
No. Well, not really.
What about the bubbles tell you that it's a chemical reaction?
Because that's kind of scientific. That's science.
Because it like
It changed the substance.
yeah. So did the reaction stop, or is that a signal that it's still going?
It's still going.
Okay, so we put the powder in here, and then we put the vinegar up in here, and it bubbled up all the way to the top.
Okay, so what was the powder?
Baking soda.
How do you know?
I can just tell.
Is that the formula for baking soda?
Maybe.
So you saw bubbling. Were they big bubbles, little bubbles?
Big and little. Yeah, just a mix. It was a mixture.
How long did it bubble for?
Not very like a minute.
Only for like a couple seconds.
So when you were writing down the evidence portion of your data table, thank you, what evidence did you write down?
You mean, well, Marcion was trying to
It's physical change.
Okay, you said it was a physical change, and what made you think that it was a physical change?
Because it bubbled up.
And what definition did you write down for physical change yesterday?
and change that affects only the physical properties.
And what's the definition of a chemical change?
A change that produces one or more new substances.
We took one. How many substances did we start with?
2.
And how many did we end up with?
1.
So when you go back to your definition, is this a physical change or a chemical change? So chemical change, what did you say?
Physical change.
It bubbled up. And you know, it's good to know the time frame. Did it bubble for a long time, a short time, maybe 5 seconds? Add that, that's important. Because you may see similar substances at another station. And maybe it'll bubble for longer. So that'll be a clue for you. Nice work.
Thank you.
Oh, we poured that inside of here.
Did you read the directions?
Yeah.
Okay.
So that got to
And
be
heat.
In the crucible.
Yeah, that's the
So we
crucible.
put that on top of that.
That one on that one.
This goes into the triangle, so you have your flame going here. Okay. So, you want to do this? Typically, this is how you place a crucible on a triangle.
Pour it in there.
Okay. And I'm going to let you. There's some more in there still. Knock it on the table to just look. Oh, well, that works too. Okay. Now you're going to use this to put the crucible on the triangle.
All right, put the flame on it first.
Hey, put that on there.
Get this dice on.
Did it go far through?
You can touch it. It's not hot. It's just when you get ready to take it off.
Alright.
You want to use the tongue. Okay. Place your
That hot?
Bunsen burner. It's not hot down here.
I was gonna touch it right there.
And what does it say to do?
Place.
10 ml dihydrogen oxide and heat. How you pronounce that? Like
Hold on a
artificially?
second. Were you supposed to put something else in there before you put it? Okay. Okay, so A and B.
That's a chemical change. It's burning.
What do you notice? What's your evidence?
It's turning brown.
Okay, so it's changing color.
And it's bubbling.
It's bubbling. What else do you see?
Boiling.
What else do you see?
It's burning.
And it's turning to liquid.
Turn the gas off. Because now it's on fire.
Oh, that jump.
Okay. So see how that's on fire? You can blow that out. So what else do you see as evidence?
Like sludge.
It's like
Sludgy substance.
It's like burnt.
eruption.
What's coming off of it?
Smoke.
Okay, didn't you say yesterday that that was a piece of evidence that would suggest chemical change?
Yeah.
Chemical change.
Do you agree?
Yeah.
He says chemical change.
Oh shoot, I'm writing this down.
So maybe this is something we need to look at. Did you write it down? No. So this is something we'll talk about then.
You lost fair and square.
Okay. But I want you to be able to tell me why you think it's a physical change since you said it was a
And it's heat. Change the color. So it's always chemical.
Chemical is a change.
Did we create a new substance?
I mean, same substance, just a different color.
Okay, that's a good.
So it'd be physical. Physically, it changed.
I like the evidence we came up with. So that's the evidence that we have to
So, alright, we should have did that 30 seconds. Alright. We're gonna wait till it hits 12. Count down when I say start.
So what do I for the supporters out?
This part changed into bubbles.
I said
And then
it
it
was
went
chemical
liquid.
because, yeah, for the substance, the chemicals react to each other.
Okay, I'm going to urge you. Let's go back to your definitions that you came up with yesterday.
Okay.
Read them
A physical
again.
change, a change that affects only physical properties. This is a physical property.
Alright, Kendra, your turn.
Say a change that produces one or more new substances.
So let me ask you this. How many substances did you start with here?
2.
How many did you end up with?
2.
She says one.
It's 2. Because it really ain't.
This looks like a mixture to me. Like one thing.
But I still see the baking soda in there.
But it still would be one. This would be. I'm not going to confirm or deny that. We'll have a discussion about this
So
tomorrow.
it's physical.
So chemicals in.
You got to convince him. He needs more evidence.
It didn't create a new substance.
Yes, it did. It bubbled up.
Just like that man over there.
So why is the baking soda going to the bottom of the beaker? Why is it still separated?
It's not stirred up. What do you mean?
Why does it, if it created a new substance, it shouldn't have to be
We
stirred up?
done. Why are we still here? Hey, wash that out. Please.
I just washed out the last.
So how is it chemical? So I put it for a reason. I'm seeing two separate substances.
Chemical change, so it has to like the color will change. And it was right because when we put BTB in, and then well both of these turned it like a fuchsia color, and so that's how we thought that it was chemical.
And what was your evidence?
The color change.
Was there anything else that happened?
No, not that I saw.
How's it going so far? Okay. How many chemical changes have you seen so far?
Like 3. We only saw one though.
What kind of similarities have you seen with the chemical changes?
It was all color except for one. Like it was kind of like they were both clear, but when you had the flakes or whatever, it was like white.
Okay.
So we saw that was a chemical change. And the physical, it almost was like nothing happened, but the two they combined, but you could still see each substance. It was just physically together.
I can't wait to talk to you guys tomorrow when we go through this. All right. Nice work. Keep moving.
Right now.
Let's go to the first one. All right.
All right. So what did you guys? Did I miss it? I missed it.
Yeah.
Okay. Is this your product that you came up with?
Yep, and we just poured that one out too.
Okay. So what were you using?
For this one, we used KI and pH in the thing.
So from your, what is this, 1A?
Yeah.
What did you find from 1A? Did you have a chemical change? Or, well, first of all, what did you think was going to happen here?
I honestly didn't know, you
We
know.
didn't think
So I'm
that was gonna
prepared
happen.
for it.
Okay.
First nothing happened.
So when you did the chemical or physical change, which decision did you finally come to?
We did chemical for this one
And why did you do that?
because why?
Why did we do that? Why did we put physical?
Chemical.
Chemical?
Around the front.
New substance.
It was a new substance. How do you know it's a new substance?
Because it mixed together and it changed color.
Oh, so you started with these two items?
Yep.
And you ended up with that yellow? Yeah. Okay. That sounds like a good indicator that there was a chemical change. And what evidence did you write down for your chemical change? Yeah.
Chemical and physical change.
I didn't hear you.
Chemical and physical change time together.
Okay, so there was that big color change. Okay. And you said physical change.
Physical, it dissolved in the water.
We'll talk about that some more tomorrow too. After you've seen some things. Nice work. Don't let me interrupt you. The procedure for this station, what did you think was going to happen? What was your hypothesis?
I thought it was going to turn into gas.
Okay. And what are you seeing so far?
Yeah, it turned from green to yellow, and now it's turning orange and then red.
So my question is, how do you know it's a physical change?
Chemical makeup hasn't changed. It's still the same substance, just a different color.
If you put it in cold water, it's going to turn back to orange.
Okay. That would be a neat thing to try. Have you don't know that for sure, right? So when you're done, let that cool. We'll set it to the side and let it cool, and then we'll see what happens when we add cold water. It's a good guess, a good
Where are we
hypothesis.
going to set it on the side at?
Actually, let me grab I actually have a beaker I can sit it in, and we'll sit it by the sink. Here. Ladies and gentlemen, listen up. The data tables that you all came up with, in this class, for the most part, they were very similar. This is a good representation of what I saw. There were a couple of other styles that I saw. I'll show you what they look like in a second. What I liked about how you came up with these is you actually read the lab, and from the lab you pulled this out. Okay? So if you take a look at the screen here, you noted the station that you had. You move this up. Okay. You made note of the station, and not every station had an A and B part. Okay? For example, 4 and 5 were just one part, but this person delineated which part and which station they were talking about. Here, you decided basically, is this a chemical or a physical change in this column? For your evidence, there's a lot of evidence here, okay, based on what they saw, and then your hypothesis. Now, typically, if you were doing a data table, you put the hypothesis first because you want that to be the first thing you do at each lab station. But the fact that it was added in, as long as you started in that column, you're good. Okay. Let me show you another format that I saw. I have to draw it. This is another example of a table that I saw. So, oops, sorry. It looks like So instead of breaking up 1A, 1B, 2A, 2B, all that, instead of breaking it up along the side, they actually made an A column and a B column. So obviously numbers 4 and 5 didn't have a B part, so or 7, so they wouldn't have any data on that side of the table. But this was another alternative. Okay? There's actually one third kind that I saw, and I can't remember, but I will get a copy of that and show you tomorrow. The point of this, why am I showing you this? There's really, listen up. Excuse me. Go ahead. Right. Sometimes when you read a lab, you're responsible for coming up with your own data table, your own graph, okay, and sometimes your own procedure. And so this was just good practice at identifying different ways to put together the information that you're being asked for. Okay. Now let's take a look at your data. One of the other skills that we need to make sure that we're aware of and that we get good at is actually writing about what you're doing. Writing about that data, right? So if you take a look at your data table, and this is what we're going to work on in a minute. I just want to get you started. You take a look at your data table. For many of you, have this person. All right, for this group, excuse me. For this group, if I'm looking at just station 1, I need to be able to report my findings, to write about what I found. It's in a data table, and sometimes that's a really quick way to identify things. But when you're reporting, the reason we report our data is so that we clearly communicate what we found and how we found it. Okay? So if I were to write about this, I might do something like this. So for station 1, let's say I had to write about this entire data table, and I'm just going to start with station 1. Excuse me. Say that again? Okay, so Kiara is suggesting that we should start with our hypothesis. So what words could I put together to start describing my hypothesis? Well, I have to say, I have to specifically report that I'm talking about station 1.
It's station 1A something.
Okay. In station 1A. So let's back up for a second. Let's back up for a second. Imagine that I said, okay, you need to do this part of your lab report where you're recording your data. How are you going to describe to me what you found in station 1? Did you guys hear Kendall? No. Okay. She's suggesting that we start differently. Can you say that again?
Before I began working in station 1.
Okay, so remember, Kiara said we should start talking about the hypothesis, and it sounds like we're going in that direction. So before I began working at station 1, I thought a new substance would be formed. So she told us her hypothesis. Okay. But now what should we do? Because state what actually happened. So how should we continue this, Alfonso?
Thank you. How do we finish this?
Yeah. Well, okay, so Kendall is suggesting that we talk about what we thought was gonna happen, but now we need to say what actually happened, right? So she put what she thought was gonna happen. How do we continue this sentence?
Then put what happened.
So, but how do I word that?
From observing.
So during the experiment, and what actually happened at station 1?